Welcome to the preview exercises for College Algebra's lesson 28. The size of the initial rabbit colony, with T in years, which settled on the planet of Rabbit Utopia, was 1,000 rabbits. If the rabbit population increases by 1,500 rabbits each year, we want to fill in this table and find a function P of T that models this population growth. All right, so we have 1,000 plus 1,500 is 2,500, plus 1,500 is 4,000, plus 1,500 is 5,500, plus 1,500 is 7,000, plus 1,500 is 8,500. So in a formula or for P of T would be, well, we start with 1,000, and we add 1,500 every year for T years. And this is a linear function. 1,500 is my slope, 1,500 rabbits per year. But let's say our rule for how the rabbit population grows is different. Rather than adding a certain amount every time, we're going to double every year. So we're going to multiply by 2 instead of adding 1,500. So if we start with 1,000, in year 2 we have 2,000. In year 2 we have 4,000. In year 3 we have 8,000. And in year 4 we have 16,000. Year 5, 32,000. We double every year. And then a little way of rewriting these numbers, 1,000 is actually 1,000 times 2 to the 0, because anything to the 0 is 1. So that actually says 1,000 times 1. 2,000 could be rewritten as 1,000 times 2 to the first. 4,000 could be written as 1,000 times 2 squared. 8,000 could be rewritten as 1,000 times 2 cubed, because 2 cubed is 8. 16,000 is 1,000 times 2 to the 4th, and 32,000 is 1,000 times 2 to the 5th. So a formula for P of T would be 1,000, and then we're doubling every year for T years. So 1,000 times 2 to the T. And what kind of function is this? Exponential. Right? This is the difference between linear and exponential growth. With linear growth, you are adding a constant amount every year, and with exponential growth, you're multiplying by a constant number every year. So let's see if we can recognize linear and exponential growth in these models for city populations. So which of these cities have populations that are changing exponentially? That would be B and C, because they're being multiplied by a certain number every year. What is the initial population of city A? So initial population, that's the population at time 0. So you plug 0 in for T and you get 300. For city B, if you plug 0 in for T, you have 300 times 1.3 to the 0. Anything to the 0 is 1. So that's just 300 times 1, which is 300. And city C is 600 times 0.978 to the 0. That's 600. And let's describe in words how each of these populations is changing over time. So for city A, our initial population is 300, and then we're adding 1.3 thousand people every year. So city A's population starts at 300,000 and adds 1.3 thousand each year. Now city B also starts at 300,000 right? But it's increasing by a constant factor. My growth factor is 1.3, which means my percent change is 30%. So this is starting at 300,000 and increasing by 30% each year. And then P of T starts at 600,000. $600,000 people. And then 0.978 is my factor, it's a decay factor because it's smaller than 1, right? So if I multiply 600 by a number smaller than 1, I'm going to get a value less than 600. So this is decay. And 0.978, that's 97.8% of the population that stays. That's the population that remains. So if I'm keeping 97.8% of the population, that means that it's decreasing by 2.2%. So we're starting at 600,000 and decreasing by 2.2% each year.